Hello viewers, welcome again. There we go, still with 2023 KQ projections. Like I told you, today is a different day, and according to the public demand, our learners have requested us to stand with them by revising the past papers. And the question comes from 2021 KCSE paper 2 mathematics, according to their choice. So there we go at number 4. The question reads, two variable x and y are such that y varies directly as x power n, where n is a constant. Given that y is equal to 320 when x is 16 and y is equal to 2560 when x is 64, find the value of n. 3 good marks. So guys, before we continue, let me take this golden opportunity to thank you gratefully for standing with us, for subscribing, for supporting this noble cause, and for sharing knowledge. So we have no better words but just to say thank you. So as we continue, to my learners, going straight to our solution, what a unique question for us here. So I want us to take time and digest the question and be able to formulate the relevant idea behind this. So under variations, there we go. We are told y varies directly as x power n, and therefore reducing this into linear equation, we shall have x is equal to a constant k x power n. We have to introduce a constant, doing away with the variation sign, and therefore now substituting the values given, we are told y is 320 when x is 16, so k times 16 power n. Then equation 2, this is equation 1. Equation 2, y is now 2560 when x is now 64. So k is still there, 64 power n. That one gives us equation 2. So we have two equations and we have to solve them by any appropriate method. So the first thing I would want us to look at the question keenly. As you can see, familiar numbers are 16 and 64. So I want us to convert them into a common base. And the common base is, so I will have 320 is equivalent to k into 2 power 4n. Writing 16 into base 2, it shall be 2 power 4. Of course, times n was there. Then the same to 2560, k into 2 power 5, power 6n. 2 power 6 giving us 64. I hope we are still together up to that stage. Then let's make k the subject in each case, and therefore from equation 1, k will be equivalent to 320 all over 2 power 4n. I hope we can see that clearly. I am dividing by 2 power 4n on both sides, so that, and again, excuse me, and again, the other k in equation 2 will also be equivalent to 2560 all over 2 power 6n. That one has come from our equation 2. So both of them are representing k, and therefore we are going to equate them. So k in the first case is equivalent to k in the second case, and therefore what are we going to equate now? We are going to equate 320 over 2 power 4n should also be equivalent to 2560 all over 2 power 6n. There we have them. So coming over, let's pay attention and see what is going on. The question looks a bit tricky, but very easy. So I would want us to cross multiply so that we shall have 2 power 6n by 320, of course. Then on the other hand, we shall have 2560 times 2 power 4n. 2 power 4n. Then I want to collect the two powers, the indices, the numbers with a base, and collect the other whole numbers together. So I'm going to divide this side by 2 power 4n, divide again by 2 power 4n. So this one shall have cancelled. And I want to eliminate 320 by dividing by 320 also on both sides. So on the left side, 320 shall go, and we remain with 2 power 6n over 2 power 4n. I've tried to group the indices together, or the basis of 2, the numbers with the basis of 2. So on the other hand, we shall remain with 2560 over 320. So this question is long gone. So cancelling the zeros, now obeying the law of indices, when the bases are divided, the powers are minused, and therefore we shall remain with 2 power 2n. That is 6n minus 4n is equal to 2n, which is equivalent to, dividing through, we get 8. So we can be able to, we are able to convert 8 into base 2, and therefore 2 power 2n will be equivalent to 2 power 3. And therefore, when bases are the same, it means the powers are also the same, and therefore 2n is equal to 3. Dividing by 2, divide by 2, then n becomes 1.5. So thank you very much, guys, for following, for listening. Without you, we are no more. To our learners, pay attention, follow through. Just to go through very briefly, I said, given that two variables, x and y, are such that y varies directly as x power n, where n is a constant, we have been given values of y, that is 320 when x is 16, and again y, 2560 when x is 64. So we are told to get the value of n. The first thing I've said, we formulate the correlation, and therefore we have said we introduce a constant so as to do away with the correlation sign, or the proportional sign. So having a constant k, we substitute. In the first case, we are told n is 320 when x is 16. In the second case, when y is 2560 when x is 64. Looking at these questions, they look very funny or unique, and therefore we have to be very critical. So the first thing here we can see, which is similar in both of them, is k. So we have to make k the subject in each case. I've made my case the subject in each case. So we have to equate them. The k's are just the same thing, or the same constant. So equating the k's, and I've tried to recollect recombination of this of the equations, where I've tried to bring the indices together and the numbers, or the constants together, and therefore dividing through, I'll be able now to apply the law of indices that states when bases are divided, the powers should be minused, and that is what I've done here. 6n minus 4n is 2 power 2n, and therefore dividing through this side, we get 8. Written into base 2, it is going to be power 3. Equating the powers, because the bases are the same, we get n as 1.5. So let's learn together. Let me promise my students again, you can never miss a question of variation. It's either partial variation, joint variation, or that is a homework I'm leaving with you. We all know the three types of variations. So joint, direct, and partial. So thank you very much, guys, for giving me your ears. Please, let me ask for the last time now. Let's share, subscribe, and let's make a difference in the life of our children of tomorrow. Thank you very much. You can reach Mr. Peter or the Beacon Master on my number 0720 9685 and 17. Thank you and bye bye.